Hello, ladies and gentlemen. Thank you for joining me on our last study plan together, stoichiometry. If you don't already have it out, go ahead and get out a periodic table and a calculator. So, we have four study topics for this unit: mole to mole, mass to mass, limiting reactant, and percent composition. Right there is all the vocabulary that you need to know. Here are the formulas for the unit. Make sure you write those down if you are one of my remote students. If you are in person, they will be on the test that you are given. For number one, we have identify the mole ratio. So our first one is AlCl3, aluminum chloride, to hydrochloric acid. So we're just going to write our mole ratio. We're going to start with a 2 because that is the coefficient in front of AlCl3. And on bottom, we have HCl. In front of our HCl, we have a 6. So just 6 moles of HCl. All right. For our second one, we have aluminum to H2. Again, there's a 2 right here in front of our aluminum. So we have 2 moles of aluminum. And then on our bottom, we're going to H2, which is a 3. 3 moles of H2. Our last one is HCl to Al. So we have 6 moles of HCl. On the bottom, we have 2 moles of Al. Okay. Again, you're just looking at the coefficients, going from your known to your unknown. That's it. For number 2, you can do mole to mole calculations. So our first question is, how many moles of zinc phosphate are needed to react with hydrogen gas to produce 2.65 moles of phosphoric acid? What we're starting with is 2.65, and that's moles of phosphoric acid. We are given this problem right here. We have to figure out which one is phosphoric acid. We all know that all acids start with H, so this last one is our phosphoric acid, so it goes here. Okay, we put that all over 1. Then we're going to multiply by our mole ratio that we found in our last step. Because we have moles of phosphoric acid up here, we're going to have moles of phosphoric acid up down here. The number in front of our phosphoric acid is a 2. So we have 2 moles of phosphoric acid. On top, we are going to how many moles of zinc phosphate. In front of our zinc phosphate, there is no number. So I know that is a 1 mole of zinc phosphate. Then I'm going to go ahead and do my math. In order to put that in the calculator, we're going to put 2.65 and divide it by 2 to get 1.325. And our units that we're left with are moles of zinc phosphate. Okay. Our next example is if 0.613 moles of copper reacts completely with silver nitrate, how many moles of silver will be produced? If you are my in-person students, I did change this from copper because you will get the same answer. So we're going to start with 0.613 moles of copper. So copper is the Cu. We put that over 1. Then we're going to write our mole ratio. On top here, we have moles of copper. So down here, I know I'm going to have moles of copper. In front of my copper in my balanced equation, there is no number, so I know it's a 1. We are going to how many moles of silver? So that is a 2, because the coefficient in front of our silver is a 2. 2 moles of Ag. So we're going to take 0.613 and multiply it by 2 in our calculator and get 1.23. That is mole ratio, or going from mole to mole calculations. For section 3, we are going from grams to grams, or mass to mass. We're using this rather large equation that we were given way up here, this big long one. Okay, so if you don't already have that written down, go ahead and take a minute, pause it, write it down. We are always given an equation and always asked to go from grams of one thing to grams of another thing. So in this example, we are going from 26.8 grams of lithium chlorate to mass of lithium chloride. I'm going to start with my 26.8 grams of lithium chlorate. Now, this first one is our lithium chlorate. We're going to put that over 1. On the bottom in our next step is our molar mass. In order to figure that out, we're going to add lithium plus chlorine plus 3 oxygens. Some of these I just have memorized. These are all found on the periodic table. Lithium is 6.94. Chlorine is 35.45. Oxygen is 16. So we are going to add all of these together. Make sure you multiply that O by 3, because there is that subscript of 3. You should get 287.08. So that goes down here as our mass. On top, we always have 1 mole of our given. For our next step, we have our mole ratio. On the bottom, I'm going to cancel out this moles of lithium chlorate. In front of my lithium chlorate in my balanced equation, I have a 2. So I know on bottom, this is 2 moles of lithium chlorate. On top, I know why I'm going to lithium chloride, because it says what mass of lithium chloride. So that is also 2, because in our balanced equation, before lithium chloride, we have a 2. LiCl. Our very last step before we do our math, I have moles of lithium chloride here on bottom. I need 1 mole of lithium chloride. Now on top, I'm just going to add my lithium and chlorine together to get the atomic mass. So that is just these two, my lithium and my chlorine, 6.94 plus my 35.45. To get 42.39. And that's grams of LiCl. Now, The last step for all that equation is to put it in a calculator. How I do it is if it is on top, you are going to multiply. If it is on bottom, you are going to divide. You can ignore the ones. So right now in my calculator, I'm going to take 26.8 times 2 times 42.39. And then I am going to divide that by 287 divided by 2 and hit enter. Guys, I got the atomic or the mass wrong, the molar mass wrong. Now I put all that in my calculator. My answer, much better, 12.71. And whatever this top is, this last unit, that is the unit on my answer. Now, in order to get this whole question right, you have to have all of the units on every single problem, on every single part of the problem. You have to show me your answer. With units as well. All right. Our next question, 3B. We have how many grams of water are produced from 156 grams of B2H6? So we're going to start with 156 grams of B2H6 over 1. The bottom, I'm going to need the molar mass. Borons, molar mass is 10.81. Hydrogen is 1.01. So I'm going to multiply and add those together. To get 27.68. On top, I have 1 mole of my same substance. Okay. Our next multiplication, our next factor, we are going to switch to our other substance. In this example, it says how many grams of water. So on top, I need moles of water. The number in front of my H2O is a 2. So this is 2 moles of H2O. On the bottom, I still have my B2H6. In front of there, I have no number, so it is going to be a 1. In our final step, we're going to go from moles of water, so that goes on bottom because these need to match. On top, we need the molar mass of water. H, we have 2 of those, 1.01. Then we have oxygen, which is 16. When we add those together, we get 18.02 grams of H2O. Once again, when I put it in my calculator, if it's on top, I'm going to multiply. If it's on bottom, I'm going to divide. So I have 156 divided by 27.68 times 2 times 12.02 to get an answer of 135.49. And our unit is grams of H2O. All right. For our next question, we have two limiting reactant problems. So we're going to do all of that twice. Okay. For our first one, I have 46 grams of oxygen, and the other one is 57 grams of glucose. And glucose is the C6H12O6. All right. Our next one, we're going to do the molar mass on bottom for O2. That is 16. No, it's not. It's 16 times 2.